All right, so you've seen this little graphic before, and this blue graph is obviously just some strange function. Begins at -1, ends at 3. Okay, the domain is from -1 to 3. And what you see there is a sketch of the derivative, okay, as it moves along. Green means the derivative is positive. Black means it's 0. And then red is negative slope, okay, of the derivative. So what we're going to do is we're going to take a look today at something called the first derivative test. So as you look at this graphic right now, what you're going to see is, first of all, on this graph, we see that this is a local, what? What is this? A local maximum, right? Because it's kind of a hill, right? So there's a top of the hill, a local maximum. It's local because if we focus, weird. If we focus right on, if we zoom in, can I zoom in? Yeah. If we zoom in just on this peak right here that you see, all of the other values around this point that represents the max, all the other values are lower, right? So this is the highest y value here. So what I want you to focus on is what's happening to the derivative leading up to, occurring at, and then immediately after. It goes very quick. But how would you describe the slope of the tangent line leading up to, at, and going away from, on the right, the local max? What would you say, someone? The derivative is what? Finish that sentence to describe what's happening around this local maximum. Anyone? Okay. The derivative is, okay. I heard positive and I heard increasing. Let me stop on increasing first of all. Okay, I don't know if I can stop this thing. Okay, I don't really stop this thing. It just keeps going on. But as it leads up, okay, so let me just do this. I'm going to do something really fancy here. Ready? As it comes up to the local max, okay. All right. Well, that's quite a delayed reaction there, but I'll try and just. You know what? Actually, whatever. Let me just print screen this thing. Okay, hang on. Where's my print screen? Okay, ready? Okay. Print screen. Let's see if this is going to work. I come over here. I'm going to add a page. I'm going to put my print screen on there. And not bad. Okay, so let's make this a little bit bigger. Okay, so this is one snapshot in time here. My pen. Oh, great. This is a wonderful lesson so far. Okay, so someone said positive, someone said increasing. The increasing. Notice that the slope of the derivative coming up to this point right here, it's actually decreasing. It's actually getting smaller and smaller and smaller as it gets close to this maximum point. So the derivative is not increasing. The function is increasing. The function is getting higher and higher and higher. The function is increasing. The derivative is not increasing. The derivative is actually decreasing. It's going from a very large positive down to close to 0 at the top. So it's not increasing, but it is positive. Okay, someone that said positive, this is a positive slope. And everywhere, whether it's increasing in this section or decreasing in this section, everywhere the derivative is positive leading up to the local max. And so now if we go back here, okay, and we look at exactly at and after, okay, so let me plop down here another snapshot. There we go. So after the local max, the derivative is negative, right? It's negative afterwards. All of this is negative. And even just after the maximum point there. Now, at the local max, we've already determined this, that the derivative is 0. So that is the essence of the first derivative test. If you examine the derivatives on the left side of the critical number and the derivatives on the right side of the critical number, you will be able to tell whether it's a local max, a local min, or neither. Okay, so again, I just want to show you this graphic. Positive, 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 0, negative, 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 negative. In this area, this is a local max because it's positive, 0, negative. This one over here is also a local max. Is there a local min? You bet. Let's watch this one down here, the local min that's coming. Okay, this roller coaster. So we have negative, 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 0, positive, positive, positive. So immediately surrounding this right here, we have negative to 0 to positive. Okay, one more thing I'll show you on this graphic before we leave it. This point right here also has a derivative of 0. Is this a local max, a local min, or neither at x equals 0 here? What is it? It is neither. Notice what's happening to the derivative. It's positive, 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 0, and then positive, positive, positive again. So it kind of comes up, it flattens out briefly, and then goes back up again. Neither. So the first derivative test, if we test the derivatives to the left of a critical number and it's positive, and then to the right of a critical number and it's still positive, if there's no sign change, we do not have a local max or min. Okay? First derivative test in a nutshell. You good? You like this graphic? I still think of this graphic as like a bit of a roller coaster. Wah! It's just screaming. Kids are screaming here. Yeah. Oh no. Oh no. Oh no. Ah! You know, screams right at the end. Okay. So the negative slopes are screams. Okay. And the positive slopes are like dreadful anticipation. 0. Ah! Okay. So think of the negative slopes. Is that going to help? It's going to help. Okay. Good. That helps me. Okay. Enough of that. Back to the notes. What are we on? 4 point what? 3 or 4? 3? All right. So first derivative test. Here we go with the lesson.